Welcome to the YouTube channel Command Line. In this video, we are going to learn about KExec. First, we will learn what is KExec, and second, we will see why it is necessary and what are the use cases it is being used in Linux world. Then we will go little deeper into the mechanism and see how it is implemented in the kernel and user space. At last, we'll have a quick demo. This is the normal flow of system boot. Usually when the system is powered on, firmware will come into picture and then it will load the bootloader such as like U-boot or UFI. Then the bootloader will load the actual OS. Usually this will be like Windows, Linux or any OS like Mac or Solaris. But with KExec, firmware loads the bootloader and the bootloader loads the Linux, and Linux can act as another bootloader and it can load one more Linux also. You may wonder why it is necessary. So the bootloader is already loaded Linux and Linux is running. And why the Linux wants to load another Linux? What will be the use case scenarios? So I can think of two scenarios. One is collecting the crash dump. For example, when a system crashes, the only way to recover a system is rebooting. When you reboot the system, all the system memory contents will be vanished. You cannot have a dump for analysis. In such scenario, the kdump will be useful. For example, when the system is initially loaded, we reserve a specific amount of memory and in that memory we keep another kernel. When the system crashes, the second kernel in the reserved memory will be booted and that will dump the entire system memory into hard disk. So later on, that stored memory dump will be analyzed for crash analysis. The other scenario is if you are having a proprietary OS or a software or an algorithm running in your Linux OS, you may worry the hardware may be tampered. For example, you are an AI company, you don't want the algorithm to be exposed to external world. So you want to be very sure that the hardware is not tampered before loading your OS. So you can have two different OSs. The first OS will boot and then it will check the hardware integrity and everything is safe. Once it determines the things are safe, then it will load the actual OS which is having the algorithm or the proprietary software. These are the two scenarios I can think of. Suppose you have different scenario or you are using KXF for or if you are using KXF for different purpose, please let me know in the comment. Now let's see how KExec is implemented and how to use KExec. So KExec is a kernel mechanism. So you have to tell the kernel that you are going to use KExec. So it comes with two kernel configuration options. The config KExec is a legacy option and this was the first implementation of KExec and later they moved into a very secure one which is KExec file. So to enable KExec file we have to enable config KExec file. When the config is set, corresponding system call will be enabled in the kernel. The system call for config kexec is kexec load and system call for config kexec file is kexec file load. Kernel will start supporting additional command line called crash kernel. This crash kernel command line is used for reserving some memory in the RAM. This is our entire system memory where Linux is going to allocate for processes. In this system memory, we are going to reserve some specific area and then we will load one more Linux into the reserved memory. So the OS will not even tamper the reserved memory and it will be kept intact. It won't be disturbed forever in the life of the OS. This reserved memory will come into picture only when the main OS crashes. When the main OS crashes, suddenly the control will come to the reserved memory and the OS loaded into the reserved memory will boot and then it will dump the entire system memory into hard disk or network. Here you can see the system calls. Here you are seeing the arguments are entry, NR segments and flags. So this is not very straightforward. Usually when we load the Linux, we want to load the kernel, we want to load the user space and command line parameters and device tree and etc. But here you are seeing we are passing the segments. So the system calls expect we should initially create multiple segments and load kernel, user space, device tree, everything into the segments and pass those segments to the system call. So it is not very straightforward. So to make the life easier, kernel itself comes with the user space tool, which is nothing but kexec tools. It is part of the Linux source itself. Here you can see the typical usage of kexec. We are passing the kernel image and command line option and the initrd image. So the command line option is for the command line for the crash kernel, not for the original image. And this kexec has additional options also. You can explore other options from the man page of kexec. Now let's see the demo part. I am using an Ubuntu machine hosted in Azure for this demo. You can see it is Ubuntu 24.04 LTS. This machine comes with the kernel which is built with KExec config. You can see that by you can see config KExec and config KExec file both are set in this machine, but the system is not loaded with the KExec kernel. We can verify that by printing the proc command line. So here you can see that there is no crash kernel parameter. So it means no memory is reserved for a crash kernel. When no memory is reserved for a crash kernel, So no kernel can be loaded, no KExec kernel can be loaded. To enable KExec in Ubuntu, we have to install the user space tool kdem tools. This is asking us whether we want to enable KDM tools by default. It means we have two options. First is we can always load the KXF kernel and the machine will go into the KXF kernel upon any crash. Second option is the machine will boot with just a reserved memory, but no kernel will be loaded in that location. So after the boot, whenever we need, we can load the kernel, and from that moment onwards, KX will be loaded. I'm going to select default yes. So it is installing KXF tools. On top of it, it is going to install KDM tools and other necessary packages. So as you can see, it says no crash kernel parameter is in the kernel command line. So it is not going to use, like, KDM tools is disabled by default. So it says like no crash kernel parameter is enabled in the kernel command line. So the KDM service is disabled right now. So we have to go for another reboot. When we go for reboot, the KDM tools will be enabled and the kernel will be loaded. So let me reboot the system now. Now you can see that the crash kernel parameter is set and it is reserving the memory based on the system memory. And we will see whether the KXF kernel is already loaded in this machine. As this value says 1, it means the crash kernel is loaded in the machine. So if I induce a panic in this machine, it will actually load into the KXF kernel and that kernel will dump the memory into a file. Usually the crash dump will be stored under where crash. As you can see, we don't have any crash so far here. So let me induce a crash in this machine. Now system is entering a panic and then the next kernel KX kernel started booting. So the KX kernel's system did get triggered and it is dumping the crash. You can see it is make dump file. So it is running mk dump file proc vm core. The KX kernel has captured the crash dump and it is rebooting into the original kernel. Now we will log in and see the where crash location. So here you can see the crash dump is captured by the KXR kernel. This crash file we can analyze using tools like crash and other tools. Doing that, we can identify whether panic has happened in the machine. This is how we use KXR to capture the dump file during kernel panic. If you find this video useful, please like the button and subscribe to our channel for more videos like this. Thank you for watching.